Good day, everyone. I hope you had a good evening yesterday and a good start today. I guess this talk is a straight continuation from Robert. He just talked about AI and how you can use it in software engineering and maybe platform engineering, so helping us to do our work better. Now I take a closer look at the infrastructure part, and I will talk about AI platforms. And I hope I can convince you that you probably need one if you plan to run agentic workloads within your organization, within your company, right? So this talk is about architecting and building Kubernetes-based AI platforms. I'm Leander. I'm a managing director and CTO, work for a company called K8s. We have a booth here, so drop by after the talk if you want to continue chatting with my colleagues and me. I'm in the industry for probably 30 years now. I studied computer science in Rosenheim. This is 25 years ago, I think. And since then, you know, building software, building custom software, this is what we do as a company. And for the last 10 years, you know, it's been Kubernetes all the way, a lot of platform engineering, a lot of infrastructure. Now, let's go back in time a little. And I picked the DeLorean and I said, okay, let's go back maybe to 2019. And I looked it up. 17th of September 2019. That's the exact date we will go back in our DeLorean now. And back then, a seminal book was published. I'm pretty sure you read all that. And it was called Team Topologies, Organizing Business and Technology Teams for Fast Flows. And there's a quote from this book. And they say, too much cognitive load will become a bottleneck for fast flow and high productivity for many DevOps teams. So what was wrong back then in 2019? Well, we all did DevOps, we all wanted cloud-native development. Yes, we were responsible for the infrastructure, we had to develop microservices, and basically we could do all the good things. But we quickly realized that we had too much in our head, right? Before that, we were plain software engineers, we just coded away, and now suddenly we had so much to do, we had so much in our head, that it actually slowed us down, okay? And what they proposed in that book was basically, well, let's do platform engineering. This is what I think when platform engineering as a term was born and also as a new discipline in software engineering was born. It is a discipline designing and building tool chains and workflows that enable self-service capabilities for software engineers. So back then they suggested, well, let's tear that apart again, okay? Software engineers is software engineers, platform engineers do platforms, yeah? And let's opt for the synergies between those, make us more productive again, okay? So these platform engineers, they, well, most often develop something called an internal developer platform. I guess you all heard the term. That covers all these operational necessities of the entire lifecycle of an application. So that's what they proposed, and I guess many organizations that do cloud-native development have adopted that approach. They have an IDP within the company, and if you don't, well, then do your homework. I would suggest you should do, so that the software engineers, the cloud-native engineers, are productive again. That's a reference architecture. I took that from the Humanitech side, right? Maybe yours looks different, but I guess it kind of pinpoints and points out several different planes and several different components that are responsible for, you know, certain parts of the application lifecycle. So you have something, you know, the security plane, for example, with the secrets and the certificate handling and encryption. Obviously, you need monitoring and observability. You may have some CI pipelines. You need a registry. You have your continuous deployment pipelines. Obviously, you need a lot of resources from your favorite cloud provider, where you have like compute, data integration, networking. And up at the top, you may have your IDE. You may have a service catalog, something like Backstage. You have a source code and many, many different things, okay? So you could fill in many fancy cloud-native logos in this here now, and then you have your IDP, your opinionated IDP. Now you might ask, well, okay, we know all that. What has that to do with AI and AI platforms? And I tell you now. So let's hop in our DeLorean again and go back to 2025. This is today. And I think you all realize that by now, there is something coming, okay? Something big. There's a wave coming. And when I look at this picture, I mean, the last wave we had in software engineering is like 10 years back. That was like the cloud native wave, right? And it was really cool to ride that wave. Further back, I don't know, maybe 20 years, Agile probably, another big wave that kind of changed how we work, how we do our work and deliver software. But the current wave that's coming, that picture doesn't fit anymore, okay? It's more of these, you go to Portugal, these 35-meter waves, right? And it's cool to ride these, but probably, well, you need to be careful because if you slam here, you probably drown. So the wave I'm talking about is agentic AI, right? Robert just talked about the one part of agentic AI, and that's the software engineering agents. This is how we can leverage agentic AI to do our work, to automate certain development tasks. Semi-automate, maybe fully automate. Maybe in a few years' time. We're not there yet, but it's progressing really quickly, right? The wave is rolling. The other part I want to talk about is domain-specific agentic workloads. Okay, so this is kind of the application side of agentic AI. This is where your organization or maybe your customers, they think about automating stuff. The term out there is currently hyper-automation, what they call it. Okay, so that's the next generation of automation. So either you are in insurance or banking or automotive or wherever, there are certain things, certain tasks that are repetitive, that are boring. You may not have highly skilled staff, or you want to use your skilled staff to do like the really hard stuff, and you want to automate the boring stuff. This is where domain-specific agentic workloads come in, right? Smart agents that automate certain things. They fraud detection, they process incoming bills or something, they interface with their CRM system, they interface with their SAP system to change all these things, okay? So this is what I call domain-specific agentic workloads. Now I might say, is that something completely new? And I would say no, okay? I think if we did our homework the last years, we had the perfect surfboard to ride that huge wave. Because I think it's a logical continuation, okay? You know, I'm quite old already, so I developed, for sure, monolithic applications. Yes, I admit it. So we come from applications, we went for microservices, and now we go for AI agents. That's like a logical continuation of how we may develop software in the future. And the same goes for the infrastructure part. So we come from on-premise, some data center, okay? Most of us kicked that one. We now are somewhere in the cloud. We build cloud platforms, and the next logical continuation are probably then AI platforms that are required to run those AI agents, to run those domain-specific agentic workloads. Now, if we look at point A, okay, microservices to agents, I guess this is super simple in a way, okay? Now, I would argue AI agents are nothing more than smart microservices, okay? Yes, obviously, the inner part of an agent is probably different. You don't have that much code anymore. You have your prompts, you may have some flow control logic in there, then you have the usage of your LLM or maybe some small language model or domain-specific foundation model. But the micro agent, it has an API, it had a REST front end, OpenAI API compatible. Agents can talk to each other, like microservices could talk to each other, right? Only the protocol is different. It's like agent-to-agent protocol. Agents can call other tool servers, for example, right? So these MCP servers are basically only just a microservice from an operational perspective. And you call them via HTTP or maybe server-sent events, okay? So not so terribly new. So you could think of an agent as probably some container, some pod on some platform inside Kubernetes, maybe, if you want to build a Kubernetes-based platform. So the big question now is, well, easy, right? Are we done yet? So I have my cloud platform, I have my AI agents now. Let's deploy those AI agents onto my cloud platform. Now, unfortunately, I would say it's not that simple, okay? Because there are certain parts for agentic workloads that are different, where you need different answers, okay? Maybe more sophisticated answers, because there are things like the European AI Act that may come into place, okay? So the compliance and maybe observability might have to work different. But let's see. So let's argue 80% done. What about the rest of the 20%? How and why do we need an AI platform? Okay, so let me give you the pitch. According to Gartner, right now, 80% of all AI POCs or MVPs or whatever, they fail on their way into productive use. Okay, we did a study. You can download it at that URL down there and read it. So that is the reality. Everyone's playing out there. All the organizations, they say like, oh yeah, we want to leverage AI and agentic workloads. Let's go for it. And then they write the Jupyter Notebook, and then they realize, oh, damn, well, Jupyter Notebook is not exactly production ready. How about compliance? How about security? How about observability? How about if I give it not only 70 data points, what happens if I give it maybe 2 gigabytes of data, right? Will it scale? How does it react under load and all these things, okay? So people usually forget in all the excitement that there are other cross-cutting concerns we have to make sure, especially in an enterprise use case. I found that here. That's from a LinkedIn engineering blog, and he said like, well, it's the usual 80% fallacy of all the AI projects, and I would argue it's even less than the 80%. And they said like, well, the first 80% to get your first running agent is super easy. There are loads of frameworks out there like AutoGen or Google Agent Development Kit or Flock from the White Duck guys. And all these frameworks then make it really easy to get started, but the point is to then tweak it and get all the rest of the 20% is really hard, okay? Every extra percent makes it really hard to get it really production ready, to get it reliable, to have repeatable results, to not have bias in your AI system, all these different things, okay? And this is only implementing the agent itself. There are other challenges that make it even harder, and I would say a platform can make sure that it's not that hard, right? So key challenges are maybe technology, models, tools, and scaling. And this is a McKinsey study, and what you see here is the AI high performers. These are probably the guys that started maybe 3 years back, and then there are all the other respondents that may have started like within the last half year. And it's quite interesting that, you know, the difference between the challenges. So for the newcomers, for example, I would say, you know, strategy, missing strategy. What do we want? What do we actually want with those agentic workloads? Is a thing. AI high performers, they did their homework. They're a little better with this strategy. The data thing is really important. Okay, 11% there, 18% of the respondents said, well, they have data challenges. Okay, it's funny with AI. Crap in, crap out, okay? So you really have to make sure that you have good data, reliable data, clean data. Then there's the thing of technology. That's pretty much the same with all these. Adoption and scaling of, you know, within your organization, you have talent, and then you have the models and tools, right? So newcomers often underestimate the complexity of technologies, models, and tools. As usual, production and scaling challenges often hinder production readiness, and this is where platforms definitely can help. And again, I would argue, you know, if you come from cloud native development and now you're thrown in as an engineer into this, okay, now please build me an AI agent, I would say we have the same thing happening again back when 2019, when we did cloud native development. It's cognitive load, okay? It's a new world. It's new things, oh, you know, the models and MCP and A2A, and then you have to know the different frameworks as an engineer. So it's, you know, it's kind of feels like a Groundhog Day. Groundhog Day is the translation, right, from a Murmeltiertag. So it's like going back again. So I would say, let's talk about why we need AI platforms. And don't see AI platforms as something new, okay? See it as a logical continuation of of these cloud platforms, of these internal developer platforms. The only thing that changes is the stakeholders you want to reach, right? It's not only the developers anymore. It may be the data scientists you want to support with the platform. It may be the business owners you want to also support, right? So you now have different stakeholders in addition to the developers when you talk about AI platforms. So that's the part we already know, okay? Let's say that's the stuff we've already solved the last 5 years. You have your resource plane, compute data integration. Well, if you plan to run inference on your AI platform, maybe the compute part changes, okay? Because you need now GPUs in addition to only CPUs. So that's already something slightly different. But the rest of the part, you probably need observability, security, delivery, FinOps, definitely important, right? AI platforms with GPUs can become very expensive very quickly, okay? So have your FinOps in place and all the operability stuff. Now, the next part may be new, okay? That is a bit dependent on the platform. We talked about the data. So you have something I call the data plane. You may need a place where you have your vector databases running, right? Vector database is something kind of new that came with the RAG approach. You have your ETL pipelines that need to run there. You may have your data lake access that you want to have in your data plane. Model plane, also important, right? Model registry, versioned models, inference running here, so serving the models, maybe retraining the models if you want to have domain-specific models. So you need components there. Quality and compliance plane, super important, okay? Quality assuring your AI workloads is totally different to quality assuring maybe microservices. Because with every model change, with every data change, your chatbot can run wild, okay? So you need to continuously test. With every change, either of the model or the data, you need to make sure that truthfulness, factfulness, that it doesn't hallucinate, that there is no bias, that the tonality, so the type of the answer is still okay within your company, what you want. So, bless you. So testing for chatbots or agentic workloads is definitely a new thing, a different thing. New approaches are required. Don't underestimate compliance also. EU Act is out there, okay? It is there. So you need to have answers here also. And then I talked about all these different users. And this is what you have here. So you may have some special user serving plane, okay? Some fancy low-code, no-code UIs where maybe your business owner can kind of go to to an agent catalog, maybe to an agent catalog component and kind of instantiate and maybe just configure, hey, I'm the head of the procurement department and I want this fancy procurement agent to be instantiated and be run on the platform, right? So low entry barrier for these business owners to kind of, do their daily work. Think N8N or something, or Make, right? Just within the platform. You may have some access planes and APIs. This is for the developers, right? Serving the different endpoints of all the different models or the agents. You may have the orchestration plane, and last but not least, you may have the data modeling plane. This is for your data scientists. Maybe that's a Jupyter Hub or something, okay? So the point here is, if you've done your homework and you have some form of cloud platform, some form of IDP, it's probably just an additional layer on top of the actual platform to give that platform the capabilities required to run agentic workloads or AI, Gen AI workloads, chatbots, RAG applications, and smart agents. And you don't, so apart from the integration plane, maybe I would say you probably need a lot of that, and service plane is still a decision what you actually need. So there's a new landscape appearing. So that's the AI and data landscape. So let's play Lego and let's pick a few fancy icons and build an opinionated Kubernetes-based AI platform. I've done that for you, okay? So this is for you to try out later. So I've built one fully Kubernetes cloud native running on Google, this one. And if you have quite a beefy laptop, this is a MacBook M2 here, you can run the K3s AI platform locally if you want, okay? Apart from the inference, I left that out. So let's go. So that here maybe is an option, right? So I said, I want to run on Google. So we have a GKE cluster. We need crossplane if we want. I used Flux as my CD tooling. You have Kyverno running here. You have the standard monitoring stack. Quite nicely there. You may have a Postgre SQL and a PG vector to store your vectors, for example. You have ZenML as a framework to run your pipelines, or maybe Airbyte. On the model plane, I'm using Ollama and the Ollama operator to do the model inference locally on the cluster. This is quality plane and compliance plane are kind of new in the cloud native community still. Okay, I don't know that many options you could use there, but maybe you can use TestCube to continuously run your tests within the cluster once your agent changes. So TestCube is really cool there in combination with Captain. And maybe Ragas as a suitable framework to implement these LLM tests and these AI tests. And on the top, I chose Jupyter Hub for the data modeling plane. Flowwise AI, that's a fancy, nice, low-code UI you can deploy to kind of, drag and drop your chat bots or your RAG applications. And for serving, I said like, oh yeah, let's do Envoy and maybe LangChain4j or whatever. Now that quick look, we have 7 minutes left. That's okay. So that's the repository. Okay. So if you want to give it a go, all you need is a Google account and some money. Okay. Be prepared. So that one here is basically spinning up a 1.30 cluster with auto scaling, and I guess the most relevant lines are down here. You need to use a machine type that's capable of running GPUs, okay? So that's N1 standard 8 here. I think that's 8 CPUs, 30 gig of memory. I said, yes, please have one NVIDIA Tesla T4, please only one, okay? And it's always good to have local SSDs so that the models are served nice and quickly, okay? I forgot to check how much it already costs. I spun it up yesterday evening, okay? But I think it will cost like, I don't know, probably 80 euro an hour, okay? So be warned, okay? But the rest, if you spun up, if you use my cool makefile, then you can say, okay, make cluster, and then you say make bootstrap flux 2, and then you probably wait 5 to 6 minutes, and then the image I just showed you, this one here, you have up and running your initial MVP of your AI platform, and you're ready to go, okay? I warned you about the pricing, okay? So if you plan to do like inference within your cluster, then, precise planning, because it does get expensive quite quickly, okay? So there are different GPU machines. Have a look at these. Not all and every GPU machine is available in every region, so you need to do some planning there, okay? How far is the cluster away? Do I have latency issues maybe? Is it still within the EU, because of GDPR compliance and all that? So you need some careful topology planning here. The price is very drastically. Maybe you start with the smaller NVIDIA machines and not have H100 GPUs in there, then costs will explode, okay? I mean, we're talking about 2,500 euro a day, right, this price range. Additional SSDs, I told you, are recommended. And then you decide, is it smart to have like all nodes with GPUs in, or do I need like different node pools with like tains and labels, and you have like, I don't know, 3 machines where you run your inference jobs, and then you have general purpose machines within your cluster that run all the microservices and all the agents and these things that technically don't need GPUs. Only the inference needs. Okay, so that makes it a little more complicated to get things If you want to try, if you don't have a Google account, but you have a kind of a good laptop, then you may do this here. I'm running Rancher Desktop here, but it would work with Docker Desktop or any local Kubernetes installation. I kind of stripped it down a little, and I changed things. I use Langflow instead up there. I have VV8 as a vector database deployed. I'm doing Olama as well, and I stripped down a few things. So just to show you, let's see. Yep, we go there. So we go here, Rancher Desktop, and then we make, what did I say? Boop. Boop. And off you go. And, well, don't know what the internet connection here is. But what I'm currently doing is just bootstrapping that little lightweight AI platform variant I talked about onto my local machine. Okay? Slightly running out of time, but let's see how quickly it goes. We have 2 minutes 30 left. But give it a go, right? So all components are healthy, so Flux is there. Okay, get an S, let's see. So Flux is there, and crossplane is already starting. That's the 7 seconds. Monitoring is already, okay. Flux get all, up. Okay, up. Right, so looking good and progressing. So again, that might take probably 5 minutes. I probably continue. All right, then. Now, this might look very big and very bulky, and it's like, oh, do I need all this, all these components and all the platform? And the simple answer is, no, you don't. Okay, if you just plan to run like simple agentic workloads, if you don't plan to do the inference on the cluster itself, and instead use some, some external sources like OpenAI or Gemini from Google or whatever, then here's a simpler alternative. And this is what we call the agentic layer. And I invite you to our booth, okay? So what we think is the test bench is important. You need agentic observability. You need something called an agent catalog. You probably need something like a model router so that your agents are not bound to a specific model, so that you can kind of switch that easily. Think of a simple egress gateway for different models. Maybe some form of agent exposition, some fancy UI. So this is what we are currently working on. Open source, okay? So this is a really new project. We started as QA like 4 weeks ago, and we started work with a team of 5 developers right now. And I invite you to come to our booth and have a chat with us, and maybe you want to contribute something to make like a super thin pluggable layer on top of your Kubernetes-based platform you already have, okay? So please come by our booth. Also, a bit of a longer, maybe more in-depth demo I do on the July 31st on the Cloud Native Night here in Munich. So also come by. And last but not least, because the project is so new, please take our survey, okay? We need your input. Tell us about your problems running agentic workloads on your Kubernetes clusters. Where are you stuck, or what are you curious in? And which topic would you like us to develop first, maybe, or which component, and which topic would you like us to dive deeper in the topic, okay? So we really appreciate your feedback. So take the time. It's just a quick survey. It would really help us to develop the right stuff. Excellent. That's that. 30 minutes, very short talk. Thanks, guys.